I think you're on mute, I guess.
Good morning, everyone. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this exclusive webinar and the third in the BCIC Maxbyte webinar series on data-driven manufacturing using IIoT for enhanced visibility. The session is organized under the aegis of Industry 4.0 Expert Committee of the Chamber. I am Rupa, Assistant Secretary General at BCIC, and I have with me Colonel Harish, who is the Secretary General of the Chamber. Welcome, sir.
Good morning to you all.
The Chamber acknowledges its support to Maxbyte Technologies for its immense support in organizing the webinar series. And welcome Mr. Surendran, who is the Chief Commercial Officer, Maxbyte Technologies, for accepting the invitation to address at this webinar. We would like to briefly introduce Mr. Surendran. He serves as the Chief Commercial Officer at Maxbyte Technologies, and he spearheads cutting-edge industrial autonomous AI and digitalization solutions, driving innovation and business growth. He is currently pursuing a PhD in autonomous factory maturity models for personalized production and wholesale masters in engineering from Anna University. He has made significant contributions at Robert Bosch and GE India, leading pivotal projects in Industry 4.0 and digital transformation, solidifying his position as a key thought leader in industrial innovation. The Industry 4.0 Expert Committee of the Chamber is chaired by Mr. A. Chandramouli, who is the past president of the Chamber, and co-chaired by Mr. B. Jagannath, who is the COO of M2 Next. That's a subsidiary of you. And now I would like to welcome Mr. Surendran. And before that, we would like to acknowledge the support of our annual sponsors, our member organizations who are supporting the activities of the Chamber throughout the year. Now, over to you, Mr. Surendran. The stage is yours.
Thanks, ma'am, and thanks for the quick introduction. And good morning, all. Myself, Surendran, taking care of the complete commercial operations at Maxbyte Technologies, and having vast experience in industry digital transformation and Industry 4.0 program implementation for several customers across the globe. So we would like to, in today's session, mainly we will discuss about the key importance of data-driven manufacturing and data-driven engineering. So how these data is going to support organization for their the next transformation journey, or how they can move on to the next maturity level in their digital transformation. And what are some of the key challenges that they're going to face, and some of the key use cases that can be implemented readily for their digital transformation journey and their continuation and adoption program. Please feel free to stop, interrupt in between also for any particular questions or in detail, so that we can make the session more interactive. So once again, I welcome you all for the the webinar series on the smart and sustainable manufacturing solutions. And in that today's session primarily focusing on data-driven manufacturing using industrial IoT. So this is like kind of a key agenda for this particular session, like data-driven product life cycle. So before that, we would just quickly touch upon what is Industry 4.0 and how industrial Internet of Things is helping industries in their digital transformation, data-driven design, data-driven manufacturing are some of the key areas that we're going to quickly see or touch upon in this today's session. So as we see, every organization would have three major categories of operations on the engineering side, production, and on the aftermarket side. So engineering predominantly focuses on the work that is carried before the production or manufacturing actually happens, mainly focusing on the product design, the analysis of that particular product, and how that particular product is going to fit or serve that serve in terms of form, fit, and functionality. So once that is true, then we go for the actual production, and then the product has been made, then it has been shipped to the market, and the customers start using that market products in the market. And there is a need for the OEMs also to continuously monitor their product performance in the market, so that they can able to upgrade or optimize or enhance their product for the next version or the future versions. But what are the key challenges that today's industries face in this particular process? So mainly on the visibility side, so there's a poor visibility of the complete data, we can say, in terms of data. And most of the actions are reactive rather than proactive. So we react to failures rather than proactively stopping that particular failure. And there are a lot of operation costs that is going on unnoticed. So how we can able to bring that to that limelight and able to reduce that particular cost. And in the complete or in the modern era of increasing product complexity, so how our manufacturing can be more and more flexible rather than rigid lines. So that is in terms of operations. But at the same time, there are multiple technologies coming up in the market. So how these technologies are bundled together. So currently, every industry might have or will have different isolated technologies. And one of the key challenges is how can we upskill and reskill our workforce so that they can able to adapt to this particular emerging technology or new technologies, or what are the roadmap that we have so that we can form a clear um, digital transformation roadmap journey so that we can able to achieve our goal in terms of digital transformation. So these are some of the challenges that currently we have. So this is like kind of a basic information like most of us would have known how this industry 4.0 era started. So before we started with industry 1.0 back in 1700 where the primarily mechanization comes into picture, and then it went to industry 2.0 where electrification came, and then automation came, that is industry 3.0. So now we are in the era of industry 4.0 where we call it as cyber physical systems. Now people have also started. I'm hearing some background noise. Hello? So now we are in the era of Industry 4.0, where we are mainly talking about cyber physical systems, machine-to-machine communication. So how we can able to take the data from the machine and utilize for this effective utilization of the machines, and how we are going to rather than further optimize the operations. So now, once we talk about this Industry 4.0, now people also started thinking about Industry 5.0, where it primarily focusing on cobots and robots integration. So this is something like where humans also will be a key part of this particular industrial era. So how robots and cobots form a major source of primary a player in that particular digital transformation. So that is what the system is evolving, and industry is moving towards that particular trend and technologies. So, but what is the key difference between industry 3.0, 4.0? Even though we talk about 5.0 or 6.0, so whatever the numbers may be, but still there are a lot of areas or industries are coming up with adoption of this particular technology. Whatever we talk about in terms of operations, in the terms of manufacturing process or lean manufacturing, or we go with the experience-based decision. So now it has converted into like kind of a lifetime product lifetime. So where we talk about smart manufacturing, and we make the decision more by the data information rather than by the experience. And how can we create some new revenue streams inside the organization, which can help them both financially as well as to bringing in new cutting edge technologies as well. That is on the operation side, but on the IT side, information technologies also, there are a lot of changes that is happening where there are key IT processes are there, and then there are multiple silos processes that has been used in the system, where we can able to. There are major challenges is in how the industries or how the different technologies or the tools are operating in silos. The major concept in Industry 4.0 is how to bring that together into one single around one single umbrella, so that we can able to use it for the collective decision making rather than of a individual or silos decision making. So that is the key areas or the key change that we see in Industry 4.0. But whatever the initiatives have been changed, whatever the initiatives have come, but at last for the organization, there is only three major areas. One is maximizing the revenue growth, reduce the operating cost, and increase asset efficiency. So these are the only three major goals for any industry or organization year on year that they want to look upon and how they can improve it. And these are some kind of technologies or other aids that will help organization in achieving these particular goals. And this is one such one of the key slide also I would like to say. So digital transformation, again, it is not a one single step process or it will not happen over the night. So how can we go for a step-by-step approach so that we can able to reach the highest maturity level of this particular digital transformation? So we have 6 stages of digital maturity level. Where the first two level is like kind of a computation connectivity where we connect the machines or connect the assets in the factory and start getting the data from that one. So once we are able to connect all the assets or connect the key critical machines inside the factories or with the products, then we enter the stage of visibility. So where we can see what is happening in the system. So earlier, even sometime back, people used to record the OE, the overall equipment effectiveness manually, the energy meters, the energy consumptions manually, and they used to do calculations manually for their particular KPIs. So now we can able to see the data with that one. So what is happening in the system, and then once we are able to see the data, then we go for the next set of maturity level, that is transparency. So we can able to understand why it is happening. Say for example, my department OE is less. Then we can drill down into one particular machine which is causing the less OE. So from plant to OE, we can go into department, department to machine. So machine even to the product wise, we can drill down and see which is affecting the particular OE. The OE is nothing but the combination of three aspects: availability, performance, and quality. So availability is nothing but how much my machine is running and how much time the machine is down. Then becomes the performance. In that particular available runtime, so how much is my capacity of the machine? What is my target parts that has to be produced, and what is the actual part I am producing in that particular machine? So in that actual part produced, so what is my quality? How much is accepted or rejected, or what is the main reason for the rejection rate? So combining these two or the product of these two will give you a number. So that will at the end determines the performance of that particular machine, or we can say the effectiveness of that particular machine. So that we call it as OE. So that if a department has 10 machines, so we can calculate 10 machine OE and we can average it out and say department OE. And if plant has 5 departments, then we can calculate the plant OE. So likewise, we can able to go for like kind of a bottom-up approach, or we can say the soft floor to top floor KPIs, we can able to map it. So once the transparency achieved, then we go for the predictability stage. So with the data that we are having, we can able to predict or forecast what will happen in the future. So when my machine is going to fail or when my product is going to fail, what will be my energy consumption 6 months down the line based on the past trend. So we can able to proactively take some actions and then able to optimize that particular operation. And then the last stage of maturity is like adaptability, where the machine or the system itself behaves like kind of an autonomous system where it will recommend the users for certain actions. It will for able to monitor that particular actions, and also it will be able to reapply that particular actions into the system. And then we can able to form a closed loop system which will take care or which will run autonomously by itself. So that is like kind of a last stage of the maturity level. But most of the industries in the globe are in either stage 3 or maximum 4. 60 to 70% of industries are in level 3, where they are now started seeing the data, so started understanding what is happening in the system. So now slowly they are trying to move upon the digital ladder in terms of transparency, predictability, and adaptability. So this is like kind of a maturity level that every industry also want to progress upon. And once you start your digital transformation journey, so first try to understand what is our current level, and then to move on to the next level, what and all we should do. So we can perform that particular gap analysis and then form a clear roadmap, like 6 months roadmap, 1 year, 3 year, or 5 year roadmap. So that based upon the budget that is going to allocate for that particular implementation of projects as well. And then we can continuously monitor that effectiveness of the particular implementation also. So this is what the transformation journey or the maturity level that we want to focus on. And 4 key concept of Industry 4.0 again is like kind of horizontal integration. So where we want to completely horizontally deploy that particular IoT integrations, and then we go for the vertical integration where we go for level-based assets vertically through the factory, and then how that can be made consistent or how that can be uh, made like kind of a multi-factor implementation. And again, how people can be bought to that particular value chain is again one of the key critical aspects. So these are the four pillars of Industry 4.0. There are multiple technologies that comes up around that Industry 4.0. So what is the key main aim of this particular digital transformation or data-driven manufacturing is in today's scenarios, there are multiple IT support systems. So how can we able to form a clear interface between these support system and form a single source of data? So that will help us faster time to market. And today's flexible assembly lines are more and more rigid. So how can we able to have flexibility so that even to produce one product can our assembly line be more flexible? So how our revenue streams can be changed, how other businesses can be emerged. Now everybody is talking about air as a service, water as a service. So for example, if you take a compressor, so instead of investing a capital of 25 lakhs or 30 lakhs and in buying that compressor, so rather than the OEM is now willing to provide like pay per the volume of air that you consume on daily basis or weekly basis. So it is like kind of air as a service. Now again, water as a service, heat as a service. So everything is now like kind of a as a service concept that industry is thinking about. So this industry IoT or this digital manufacturing solutions will help them to achieve these new revenue streams or introduce these new revenue streams as well. So as I said, there are multiple technologies that is driving this Industry 4.0, where Industry 4.0 is a concept where industrial IoT is one of the major technology. Analytics will come into picture, cloud computing, our cyber security, our robotics and automation, immersive technologies like augmented reality, virtual reality, our additive manufacturing, simulations. So there are multiple technologies. Digital twins is one of the key area. So there are multiple technologies that are driving this particular industry digital transformation, so that we can able to make our decisions more faster and more reliable with help of the data, and also increase the return on investments as well for this particular technology implementation. So once you talk about this data-driven product life cycle, so as I said, the product life cycle comprises of three major areas: engineering, operations, and the product. So from the engineering side, what are the key areas or key technology that can be implemented? From the operation side, what are the key areas? From the product side, that is once the product goes into the market. So how those data can be again fed back to the system so that we can able to optimize that particular utilization or optimize a particular product performance and go for the next revisions or versions of the product. So again, so how the business has been now turned into, so as we said before, right, once an machine is down, so there will be a set of events that will occur. So people will go analyze the reasons, and then they will take some measures, and then they will try to again implement it, test it, and then again start monitoring that one. So it takes a particular amount of time. But how this digital transformation has changed that particular this thing is more of proactive rather than the reactive. So once there's a downtime, the system itself able to identify what is the reason of the downtime, communicate to the users, make them available, and then see how it can be rectified by itself, and then go on to the next level. So the time of that particular decision making process or the analysis process has been much more reduced there. So that is where the key concept of this ROI or the business angle also is coming. Uh, so we can categorize into multiple areas how this digital initiatives have been spread, and how we can name the industry. So we can say digital lagas or followers, evaluators, adapters, or leaders in the market. So almost 60% of the industries falls under the followers or evaluators still. So only 10% has been adopted, and then again 10% on the leaders category. Maybe we can analyze and see where your industry currently falls, and then we can able to move on to the next level here as well. And what are the key challenges that comes when we want to start this particular digital transformation? So again, one is the lack of strategy, a lack of training. So these are seen as a key challenges that when comes for any industry to start their digital transformation journey. Then followed by again lack of business case, lack of qualified talent, lack of use cases. So these are some of the areas that has to be addressed before starting any digital transformation. And of course, one of the key critical area is the ROI. So so whenever we want to submit whenever the operations team goes and submit before the manufacturing. So or the management team. So one of the key areas again will come under the cost aspect. So what will get out of it, or what will be the return on investment. So this is generally we follow this particular approach, that is the first industry benchmarks, mark up with industry benchmark, and then implement the solution develop, and then again calculate from the bottom up solutions. So again, World Economic Forum is one of the key uh, place where where they will release year on year data on Industry 4.0 implementations and technologies. And this is like a benchmark figure that we also taken up for any lighthouse implementation project. So in a factory, if you take productivity, we can increase maximum up to 200% of productivity. So we can, for the speed or time to market reduction, we can go maximum to 100%. Agility, we can maximum go up to 90%. Waste reduction, we can go up to maximum 45% of reduction. So these are some of the numbers, benchmark numbers that we can take. And how can we move towards that particular increase or a particular improvement in that particular KPI? For example, OE improvement. No company or no unit can achieve 100% OE. So that is like kind of a myth that is being seen there. So currently you're operating at 60% or 70%. If you move on to again 1% or 2% increase in the next year, so that itself is seen as a very big improvement. So my target would be, okay, if I'm operating 70% this year, how can I go to 78% the next year? Maybe how can I go to 78 next year, and how can I go to 80 the next year? So that is how the target or the KPI has to also to be formed, rather than, okay, I am operating 60% this year, I want to achieve 100% next year, is like kind of a impossible target that we are setting at ourselves and trying to achieve it. So rather than have some practical targets and see how it can be benchmarked with the leaders in the other industries as well. So how then we can able to see how can we be able to achieve it. So coming specifically, so this is like kind of a more and more introduction towards Industry 4.0 and smart manufacturing. So how that helps this data-driven concept in any industry. So now we can go into some specific use cases on design and manufacturing. So how that can be able to satisfy, how that can be able help you in achieving your data-driven concept or data-driven organization setup for your particular industry. So coming to engineering side, as we know, these are the key methods, we can say, like kind of a configuration, knowledge-based engineering, and a collaborative development, and the product insight-based area. So where we can able to see how these four areas will able to help us. So product configuration is something like it leads with a number of design variants for any industries will have. Say for example, aerospace or life sciences is something like they will have only less variants because they cannot introduce the products very frequently. It will take around 10 years for a new engine to be developed. Similarly, for a new machines to be coming to the market, it will take around 10 to 12 years, and then it will sustain for another 10 years. So the variants will be much lesser in those particular industries, whereas in automotive equipment, consumer products, the variants are much higher. For example, mobile phones, every 6 months you're seeing a new variant in the market. So how these product variations are handled. Uh, if you can imagine, there are lots and lots of data that has to be taken, that has to be analyzed before going on to the next product or next version of that particular this thing. So how those particular data are getting managed is something very key for this particular product configuration as well. These are some of the variety of maybe the designs that we can say, that assembling to stock, assembling to order, and then critical to configuring to order, and then engineering to order. There are various ways an industry can work on that particular product. But again, how we are going to able to manage this particular variance and for each and every product. So how these data are getting tracked from the design to the manufacturing is something very critical and key aspect in this particular data-driven manufacturing and design concept. So this is like if you take a product configurator for introducing any new product, or how the users can able to uh, if I am a buyer, so and I want to buy a new structure or for my particular factory or particular machine. So how this product configurator can make your life much more easier. So they can design online from the help of product library. They can pick and place for whatever the products they wanted, and then they can simulate in the online itself and see how that product or structure is going to able to work it out. So once they are satisfied with that particular simulation, then they can place the order, and then once the order is placed, then the machine or whatever the structure is delivered and is getting deployed at the factory. So this is the cycle that we're talking about, rather than uh, before whatever they use it, right? Go analyze, see, and then do a prototype, evaluate the prototype, see how it is working, and then make that as a design, and then go for some FMEAs, and then go for that particular development, and then manufacture it and then deploy it. So how the design life cycle has itself has been reduced or can be reduced with help of these data is something very critical. And one of the key aspects is product configurator. Similarly, again, there are multiple examples for that one. So this is one such example of a complete a kind of a cart, we can say, or a trolley, we can say, so where we can able to build and configure according to our need. Right from the color and the material, we can choose it and just see how it fits into your particular product, and then just order it, and it will be delivered to you in in a much lesser time than we are doing in a traditional POCs or prototypes way. So that is for this particular engineering, data-driven engineering plays a key concept in reducing this particular product life cycle time. So this is like kind of a comparison, like kind of an not like a for all the products, but like kind of you can say average time they average it to before it takes 2 days, where the customer require comes and the design team will do the technical calculation, and then manually it will be verified, and then configuration price calculation will be done, and then proposals will be prepared. So a lot of steps. So now it has been reduced to one single button click or 5 minutes, we can say, where users itself can do. They can select the product, they can, the system itself will give the BOM, the manufacturing BOM and engineering BOM, whatever is required, and then they can immediately can place the order and simulate the particular products as well online itself. So this is one example of how this data-driven design can help us in reducing this product or design cycle, design lifetime or design cycle time. The one other set of example is on the knowledge-based engineering side. So where we deal with multiple knowledges across different areas, right from the planning till the support. And there are multiple teams that will be interacting, like marketing, engineering, sourcing, manufacturing, servicing. So there are a lot of teams that will be interacting across the complete product development life cycle. And you can imagine the volume of the data that has been dealt across this particular complete product life cycle, and how these data are managed and how these data are converted to knowledge is again one of the key and critical aspect as well. So this is, for example, the now the usage of PLMs and the design automations in terms of CAD has made this much more easier for the designers as well. So earlier, the people used to particularly rely on people's experience. Every industry would have at least a couple of people with 25 to 30 plus years of experience. So where they'll be guiding the team completely. But once they're leaving the organization, the knowledge also is leaving along with them. So how these knowledges can be converted or captured in a tool, as simple as we can say, or an application, so that the standardization can be bought across the complete organization. Even on the design, the way I design will be different rather than other person's design will be, but in product will be the same. But the way the designing methodologies or design steps that we follow might be different from person to person. So how this data standardization also can be bought in is one of the key aspects of this knowledge-based engineering as well. As I said, right, so right from the planning till the support, so the data will be viewed by different team in a different way. So the system team will do in a different way. The engineering team will view the data in a different way. Manufacturing will view the data in a different way, whereas the service team will view the data in a different way. And we need a system that we can able to manage all these data and represent the view, whatever the system or the data or the people wants in that particular format, so that they can again able to take their particular design, they can able to take the particular design or reduce the particular cycle time, and also able to capture their decision making in a much faster way. So the major gap, what we want to see, so this kind of data-driven design will try to eliminate the major challenges in terms of the technical and communication gaps, and also in terms of incorrect data exchange that is happening between the design team and the manufacturing team. Because these are some practical problems which we are coming across, because the design might have gone to some various other revisions, but the manufacturing might be happening in some other revision of the product. Say, for example, if my design revision is around, maybe I am designing in version 6 or 7, but still the manufacturing will be producing the product in a version 2 or 3, where there will be multiple versions have been taken, or multiple versions has been moved across based upon the feedback from the market, feedback from the sales team, feedback from the marketing team, or feedback from the product itself. So the same team might be working upon on multiple variations. So how that has been effectively communicated to the manufacturing is something, is some one of the key challenges that has to be addressed by this collaborative or data-driven design, we can say. And some examples of knowledge-based engineering, again, from in terms of 3D part model or 3D assembly model, or in terms of drawing. For example, part model, we can say master model or user-defined features. So people who are particularly in the design can correlate to this concepts, or to this terminologies or technologies that is displayed here. In terms of assembly, so how that assembly can be made more and more intuitive, and we can say, like, with one button click, can I get my drawing out of my system? So that is the level of automation, or that is the level of data that has to be fed into the system, so that we can able to reduce our design cycle time in a much faster way. And this is how the knowledge also is getting captured in the system. So all the knowledge and the design rules, whatever we are going to use it for designing the product, is again transferred into an application, or transferred into a tool that can be used by the designers, either in any of the CAD packages or any of the PLM packages that they currently. And some examples of this design automation. So this is like kind of a NX from Siemens. So how this design automation will help them. So this is one set of process that will be followed unanimously across all the designers. So we can able to reduce the cycle time, improve the quality, and also bring in the standardization across the organization, so that whoever uses this particular tool, they're going to follow the same process and same set of standards that has been deployed into the particular tool. Again, another set of example here. And one more data that will help us, or one more area in this particular context, is on the, we call it as IETM, that is Interactive Electronic Technical Manual. So that will help on the technical illustrations of the complete product development and the landscape. So how these documents that has been handled throughout the particular product life cycle, and across by the various teams. So how these documents can easily be digitized. So how these documents can be made up to the date till the particular dated latest design and revision level, and how those particular documents can be keep on updating whenever there's a design change or revision change or version change, and how the teams are getting notified is something where this IETMs will take place, or take care of that particular the complete process as well. So as I said, right, so how this assembly process sheet can be converted into a service work instruction, how these service work instructions can be converted into a completely digital version of this particular product, so that they can able to visualize the product as well, and also carry out their operations as well in a much more effective way. So these are some of the tools or technologies that will come under this one. So the publishing, and also the content management, structured authoring. So there are different standards that is followed by different industries for the document management purpose. So S1000D or DITA are some of the standards that has been followed across industries for the documentation purpose. And these IETMs come in inbuilt libraries, so that we can able to choose whatever the data or structures that we are following, and then we can able to provide or create our own technical illustrations. Either it can be a marketing material, or it can be a work instruction, or it can be a product manual, or it can be e-catalog, or even it can be used for the e-learning and training purposes as well. So this is a process that how this ITM works, where we build either the basic input will be the CAD model, and how these models are built, and it can be published in terms of HTML or 3D PDF or any format that we wanted. So how it is getting managed. So how these ITM tools are interacting with the PLM system, so that it is always up to date with the latest revision and versions, and how we are going to use it for their day-to-day activity. So collaborative development is one of the key aspect. So where we deal with multiple ERP systems in our multiple CRM enterprise application integration, enterprise application systems. So like a PLM, ERP, CRM system or SCM. So how these completely tools can be completely collaborated, and then we can able to bring under one single roof. So this Industry 4.0 industrial IoT will help us in combining all the data from this particular different enterprise applications, and also take the real-time data from the various assets, and then perform the calculations or perform the operations according to the KPI which you need it, and the data will be displayed or customized and displayed according to your need. So that is the key concept of this particular enterprise applications integrations as well. So again, this open and social innovation is one of the concept. So that might maybe this might not be relevant to the current this thing, but this is something which will be used mostly for the industries who are in the R&D area. So how this open and social innovation is helping them in reducing their design cycle time is one of the key aspects. So this is one such example of how a complete vehicle design has been completed in 3.5 months. With help of this open and social innovation platform. So there are various open and social innovation where GE uses specifically some of the platforms, both with internal team as well as with external teams, so that they can able to collaboratively work and reduce the design cycle time. So that is one of the key aspects of this open and social innovation as well. So these are some of the examples where how the process that can be done either inside the organization, where we challenge, brainstorm, evaluate, implement, and with outside the organization, where we or we can say it as co-creation process: invite, engage, evaluate, and identify and deliver. So this is a process that has been followed both inside and outside the organization. And some of the examples for this social innovation platform, like PlanView, Retd, Hero. There are much more other social innovation platforms as well, so we can able to go through as well. And one of the key aspects is again on the digital twin concept as well. So now people are talking a lot about on this digital twin. So how the real world data can be embedded onto a digital product or digital design, and we can see the performance, and we can able to optimize on the fly itself. So this digital twin is again a particular representation. Either it can be a product, or it can be a complete building, or it can be a process, or it can be a machine. So whatever the data that we want to monitor can be converted into a digital twin, and we can able to completely monitor it. So there are a lot of integrations happening with help of sensors, gateways, or for example, if you want to connect a machine and capture the key critical KPI data from that one, either it can be a condition monitoring data or the performance data. So either it can be data taken from the PLCs, or install retrofit the required sensors for that one, and then how that particular 3D or real world model behaves, so that same can be replicated in a digital world, and we can see the performance and optimize the performance, optimize the design, and then we can see how that particular thing is performing, and then go for the actual development and the manufacturing as well. So this is one such example of a VAL, how they are converting that to digital twin, monitoring the key process, key KPIs, and then see how all can be optimized further. And then they can optimize the product again, and they can again go for the next round of version, or again replace the product or better performance as well. Yeah. So that is mainly focusing on the product data-driven design concept, where we want to again engage, reduce the design cycle time, and also how the real-time data can be again fed back into the design, so the design can be further optimized. So I'll quickly So these are some of the examples of this data-driven design, how the flexibility can be brought in more and more into the particular products. For example, this My Muesli is again a food and beverages company where they make the cereals, and they handle to about 566 billion variants of custom mixed cereals. So this is something like kind of an where users can select it and they can order it, and they will then go for the manufacturing or making of the particular cereal by again mixing some of the products, and then make it as a new version. And this is something for an Adidas this thing there, how this customization personalization is coming into picture. They are manufacturing specifically to only to New York customer. AM4 NYC is a brand where Adidas is specifically manufacturing only for New York City customers. So this is the level of personalization that people is also looking at. So how our assembly lines, our manufacturing systems is flexible enough to cope up this particular product demand or challenging demand is something pushing the industries to this cutting edge technologies and to adopt this more and more uh, new age technologies into that particular process and then see how it can be furthermore optimized. And coming into the manufacturing aspect of it, so far we have seen a design aspect of it. So manufacturing is one of the key areas. So once a product has been designed, so it can be manufactured, and there are multiple again various stages from the gate till dispatch. So from the planning, production, assembly, the quality checking, maintenance, utilities, supply chain team, enterprise application, and then operation and maintenance. So there are multiple areas where people require or digitization or digital solutions can be adapted. And there are various color codes given here. So if you remember at the starting of this session, we have talked about this digital maturity level. So visibility, transparency, predictability, and adaptability. And these are some of the use cases on this various areas. For example, how this planning and scheduling can be automated, how the job card can be furthermore digitized in the terms of production, OE, downtime management, interlocking systems, traceability, MIG SOPs, online offline quality, even the connected workforce, AR/VR based production, and assembly again, OLE is overall line effectiveness. So how those can be bought in quality, advanced quality, in say supplier quality, incoming inspection, finished goods inspection, QMS audit, RCA, CAPAs, cases. So how these are all can be digitized more. And maintenance is one of the key areas. So how this predictive maintenance or preventive maintenance can be bought in, scheduling and the daily day-to-day clerk checklist or this preventive uh, checklist can be digitized. Space management of it can be handled more effectively. And the utility is one of the key area. The energy meters, how it can be more digitized. So how the energy meters can be bought into the particular IoT system, how the data can be correlated between different other departments. Say, for example, how energy data can be correlated with the production data so that we can able to calculate how much energy is getting consumed for one product, for producing one product. So we can monitor whether we are consuming the same energy throughout the day, through the shift, through the week, through the month. And we can see why, if there is any variation, why that variation is happening. So there are a lot of insights that will be coming up based on this particular use case implementation. And apart from that, not only energy meters, any other utilities like our compressors, dryers, DG systems, CTP, STP plants, any utilities that helps plant run 24/7 can be bought into this particular system and monitored. Even our supply chain, our material handling equipments like forklift, BOPTs, so how those systems can be bought in, how again, as I said, how various other enterprise applications can be integrated, digital twins can be bought in. And once this particular all the systems are implemented, so how this infrastructure can be managed, how the application can be managed, that is mainly on the digital operation maintenance. So there are various use cases and multiple use cases can be implemented across this particular shop floor digitization. And these are some of, again, as I said, major areas like industrial IoT, immersive technologies, AI and robotics, connected people are some of the key broader area. And under each of which, what are again, several use cases or solutions that can be implemented in industries given in a high level. So again, uh, uh, it is more like kind of a microservices app-based implementations that every industry is now following upon, where we have like kind of an app store, so where we can have multiple apps and people can able to deploy the particular apps for the particular operation, and then they can start monitoring. Say for example, some customers want to start only with OE, then they will go for maintenance, and then they will go for condition monitoring, and then they will go for energy and utilities monitoring. So likewise, not only for production, for engineering, even for the aftermarket service, app-based implementations can be bought in more and more. So these are some of the areas or key use cases that we can say, like production management tools, quality system, asset maintenance, energy and utilities efficiencies are some of the areas that we can able to focus on. So like as we said, some of the key use cases. So here we can just maybe spend some time on this particular key use cases in these areas. So first is one is the digital production scheduling. So how the planning and scheduling of the complete process operation in terms of man, machine, material, and method can be digitized is one of the key area here. So if you can see in terms of man, how the skill level can be mapped, how their safety and environment health and safety index can be brought into the system, how the performance can be monitored, even how the attendance can be monitored. In terms of machine availability, performance, quality, maintenance checks. So in terms of material, how the material can be tracked, how the complete traceability can be bought in. In terms of method, so how the MAGs, SOPs can be digitized, how the work instructions can be digitized, how the quality checklist can be digitized. So these are some of the areas that we can able to think upon and see how the complete planning and scheduling can be digitized. So once based upon the master planning schedule, so how your individual performance or individual mission schedule can be derived, how the root code can be optimized, so that at the end of the day, you're meeting the timeline as well as we are also having the complete traceability of the production that is currently happening in the system. This is one such use case for digital production system and some of the examples of digital production scheduling, how it can be done. And as I said, OE is one of the key and critical aspect of it, where we can able to, from a plant OE, we can completely drill down into a department level OE and then go for the machine level OE. And even the machine level, we can see why the machine has been down. So what is the major reason for the downtime of a particular machine? There are only a couple of ways a OE can get affected. One is due to the machine performance, or machine is not available always all the time, or the quality of the parts produced from the machine is not good. Or the workers, skill level of the workers who's operating on a particular machine might be different. So these are the critical factors that will affect that particular machine performance. So how that can be captured more? So the machine performance details can be directly captured from the machine itself, and we can able to analyze what is the major reason for the downtime. So what is the major area why the machine is going? Either it can be a setup time, or it can be a quality rework time, or it can be some more other reason. So once we start capturing that particular data, then we can able to analyze it. Okay, why that is happening, and we can able to attack that particular key root, key cause, and then we can able to rectify it. Similarly, again for quality, why the particular quality is less? Either it can be due to the process, inefficient process, or it can be due to the wrong supply of the material, or the vendor quality itself might have been not good of the particular raw material. Now, but we will come to know only once the data is getting captured. So what is the major rejection reason, and why, how much frequently it is happening, and why it is happening? So these are some of the insights that the system is providing for the users, and then they can able to take the correct decision at the correct time. And again, it depends upon the roles. Even for the role, the way the operator logs in, you will see the data only for the machine that is allocated to him. If a line HOD logs in, you can see the data of complete line. Once a planted logs in, you can see the data of a complete plant. Once a CXO level people logs in, they can see multiple plant data. So the visualization of the particular data also can be customized according to the roles of which the people is getting logged in, and according to the roles and levels of the peoples. And also not only the live data, so how this data can be captured and it can be used for the reporting as well as for the analysis as well. So up to 10 years of data we can able to store in the system, and how those particular data can be correlated. Suppose for example, if we want to know what is my yesterday OE, or what is my last year, what is the OE percentage of my last year, or what is the machine which is causing the major downtime last year or last month, how much energy I am consuming in daily basis, in the shift basis. So these are some of the data that is required day in and day out for any operations team to optimize their particular process, and also to come up with continuous improvement ideas as well. So this kind of systems will help them in providing that particular data for them. So again, depends upon the IT policy of the organization. Either the systems or data can reside in the local on-premise server, or it can reside on a cloud server, or they can go for a hybrid implementations as well. So again, the IT policies is also comes into major one of the major areas. So only we call it as that OT IT integration. So where the operation technology and the IT technology meets, and the data from the machine is getting communicated to the IT applications or the industrial IoT application. So again, another such example like tool management system, where we primarily talk about the tool replacements. So how the tool life can be monitored. So how the users can be notified before the failure of the tool itself, so that they can able to replace it. So that will also help to reduce the quality issues or the performance issues, so that for any product that is being produced on a particular system. Similarly, the quality. So there are many quality aspects that can be brought into it. So one is the product quality itself and the process quality. So from the product quality point of view, so how that is acceptance rejections of the product quality due to various reasons. And the process quality is like our SPC, online SPC audits, our quality management system or compliance management system, how it is getting tracked, and how frequently the audit is happening in the particular system, or our RCA, CAPA, our FMEA, interlock bypassing, our managed MOC. So how these and all can be furthermore digitized it and brought into the system, so that our complete quality system is getting up and running, and that particular data is again will be used by the quality team to further optimize the process as well as the supply chain as well. So the continuous improvements in terms of case, and so how that also can be bought in. So these are some of the areas in terms of quality, that how the quality data can help us in further optimizing the system. Similarly, as I said, one of the major areas on the utilities energy side. So this presentation will just show you from the main transformer how the energy is getting transferred to each individual machine, how each machine is consuming the particular energy is getting tracked. So before maybe 5 years or 6 years before, when we started this implementation, we know for some of our customers, there will be a person going around the particular plant, noting down all the energy meter readings, and again evening going down, then noting all the energy meter reading, and then they will be taking the data and see how much energy is getting consumed. But once these type of digital systems comes into the picture, the data from this energy will help them a lot in actually calculating the energy leakages as well, or where their energy is getting unused most of the time. So the concept of used energies, unused energies also will come into picture, where how much energy is getting actually used for a production is one of the key aspect, and how much energy is getting wasted. So how much energy is getting consumed during my holidays, how much energy is getting consumed during my break times. So these are one of the key critical area, because uh, once you wanted to optimize your cost or reduce your cost, the first area is on the utilities side. So see how we can manage your utilities to the full extent, and see how the waste can be reduced. And other aspect of this one is, again, as I said before, the correlation between various data. So energy data can be correlated with the production data. So can I able to consume how much, can I able to find how much energy I'm consuming to produce one part? So am I consuming the same energy throughout the week or throughout the year, is something that will help again the team to see whether they want to go for a machine wise or maintenance schedule again fully, whether the machine is operating under the recommended loaded conditions or not, whether the operator has to be trained. So that will give them more and more insights on what they need to act upon, rather than without having the data. So you can imagine what they will act upon. So this is how this data from this various system help the users to actually take their decision or take that particular process optimization in a much more structured way, and also they can able to defend their decisions with help of these particular data. So digital paperless maintenance checklists again one of so earlier so how this checklist can be completed these days, either it can be a preventive maintenance, breakdown maintenance, or autonomous maintenance. So whatever the maintenance aspects can be, so how this can be further digitized and how the maintenance team can be notified. So whether the system is will automatically send alert and notification to the maintenance team saying that this machine is down because of this particular reason, and this checklist has not been or G6 has been failed because of this particular reason. So there are a lot of insights that a maintenance team also can get them. So it also makes their life much more easier for their complete maintenance activity. They will have a scheduled audits. The system will remind them when the audits will be happening and how the audits has to be taken place, how the records has to be kept, how the records is maintained. So the complete process, maintenance process is digitized here. Again, the asset maintenance is one of the critical area. So where, as I said, right, how the asset can be maintained, whenever there's asset failure, how that RCA, CAPAs, and how that particular the corrective action, preventive actions is again tracked and monitored. So how that has been converted to the work order. So all this again will be tracked and it will be again recorded here against each and every asset. So for example, this is we have implemented a system for one of our customers for a consumer manufacturing customers where they bought their 10 lakh assets from almost 20 factories inside the particular system. So you can imagine the volume of data that we are talking about or dealing with. So each and every asset is then being bought and they can able to perform the analysis of each and every assets. They can able to perform FMEAs for that one, RCA kappa for that one, interlock bypassing, the MOCs, schedule auditing for that particular asset. So anything related to this particular asset maintenance management can be done in a particular system. Before that, they were doing in again lot of paperwork, lot of approval process. The complete workflow and approval process is also getting digitized here. And how this knowledge system is again getting into the system, how this knowledge is again capturing into the system. So down the line, if there is asset failure, so what are the key root cause for that asset? So what are the action that has been taken for that asset repair will be automatically captured into the system. So that the next time if the same failure occurs for a similar asset, again, either the users can follow the same thing, or if the reason is unknown or reason was not identified in the previous, then the knowledge base will be updated automatically. So this is the process of completely moving into an autonomous system. So this knowledge-based system or this recommendation engine will help us in moving into a complete autonomous systems down the line. And this is like kind of I think mostly you come to the end, I guess. So this is like kind of an implementation architecture for any software registration reference architecture, we can say, where the bottommost layer will be the machine layer or the hardware layer, where any type of assets, as I said, right from the material, human, or the machines, the conventional machine, SPM or CNC machines, robots, cobots, paint booth, assembly line, our material handling equipments, cranes, air, water, fuel, gas, assets, energy meter. So everything can be considered as an asset and it can be bought into the system. And the second layer is the communication layer, where we can establish communication from each one of the assets. So either it can be a PLC based. If there is a PLC, we can directly establish the communication. If there is a system is not having a PLC, then we go for an gateway based asset communication system. And the communication protocols can again vary. Either it can be Profibus, Profinet, or MQTT or HTTPS, depending upon the PLCs and the methodology we can able to communicate. The third layer will be the business layer, where all the business logics will be running, like our production OE, condition monitoring, energy and utilities, and on systems. And the topmost layer will be the user layer. So where I said the role-based access will be given to the particular user. And based on the roles, how they can able to visualize the data is something that they can able to see from this particular application. Yeah, so this is how I want to share it in this particular session, like how, so quickly to summarize it, so how the data is helping us in taking our decision in a much more faster way. So we have seen on the engineering side how various types of applications, how the data can be used. Again, on operations side, what are the different areas, how the data is getting captured and how these data can be used in our day-to-day activity to make our decision much more faster, and it will help us to automate the system in a much bigger way as well. So now I'm open for questions. If you have any questions, can discuss. So any particular questions? Yeah, so if there is no question, then I think thank you for patiently listening for the last one of us, and then
Thanks, Mr. Surendran. If there is any questions, I will share the same to you, sir, for you to respond to our members.
sure.
Thank you very much once again, sir, for addressing on this exclusive webinar. Thank you very much.
Thank you. Thanks a lot.
Thanks a lot.